This is such a tricky and difficult problem from a math Olympiad that just 12 students could solve it. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So the problem setup is pretty much simple and self-explanatory. So we have a square here with a triangle inscribed inside this square. And our only information is that GB is the Euler line of the triangle. So the Euler line of the triangle passes through corner B, or one of the corners of this square. So the question says, what is the ratio of PB, or this segment, over this segment? There is a brilliant twist at the end, so make sure to watch it completely. So for those of you who don't know what the Euler line is, so the Euler line of a triangle is a line that passes through three critical points. One of them is the centroid. So centroid of a triangle is the center of the mass, or that's the intersection point of the medians. Another point on the Euler line of the triangle is the orthocenter. So orthocenter of the triangle is the intersection point of the altitudes of the triangle. And another one is the circumcenter. So the circumcenter of a triangle is the intersection point of the perpendicular bisectors of the triangle sides, and that's also the that's the center of the circumradius. For the centroid, there is the coordinate, so we can find the coordinates of the centroid using the simple formula. So that's the average of the sum of the x coordinates of the vertices and the average of the sum of the y coordinates of the vertices. So in other words, x sub 1 plus x sub 2 plus x sub 3 over 3. And the same thing goes with y. So y sub 1 plus y sub 2 plus y sub 3 over 3. So if you have the coordinates of the vertices of the triangle, we can calculate these, the centroid. So for today's video, I think this should be the fast approach, but there are definitely more ways. For today's video, we just stick to this centroid because we have a formula for that. If you want to use other 2 points like orthocenter and circumcenters, that would be way longer, to solve this video. So our approach is to find the slope of the Euler line using the 2-point system. So we know that this is the centroid, right? The centroid is on this line, and also point B is on this line. So we can calculate the slope of this Euler line using this point coordinates, and we also have a formula for the slope of the Euler line, and then we set them equal to kind of create an equation, and then we can solve for A, because at some point we need A kind of for the slope of one of these sides. So let's find out the coordinates of the centroid at first. So centroid, or point C here, as I named it here, so that's the average of the sum of the x coordinates of the vertices of the triangle. So the x here from this vertex is 0, right? Because we can just imagine that this is just coincides on the point of origin for the sake of simplicity. And here I just named this part, this segment PA as A and PB as 1 minus A, because AB is just 1 unit. So it was not given in the question. So we just assumed that. We put it on the Cartesian coordinate system for the sake of simplicity. They could be any points, right? It doesn't matter which points you put this triangle or this problem inside. So we just assume that this, for example, this corner of the square D, it is just located on the point of the origin. So let's now calculate the centroid coordinate. So that would be, 0, so point P is A and 1, right? So 0 plus A and plus 1, which is A plus 1 over 3. And then the y coordinates, so that's 0 plus 1 And then here, that's, again, 0 over 3. So that's 1 over 3. That's the coordinate of this, the centroid. So now let's, using these coordinates of the centroid, let's find out the slope of the Euler line, because we also have another point on this, which is point B. So using this, the slope formula, using the coordinates of these 2 points, we can say that the slope of a line between these 2 points is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In other words, that's the tangent of alpha, right? The tangent of the angle that is formed between the line and this x-axis. So we can say that y sub 2, so that's the second point here, so that's 1 minus y sub 1, so that's 1 minus 1/3 over x sub 2, so that's again 1 minus x sub 1, that's a plus 1 over 3. So that's the slope of this Euler line using the first method. Let's just simplify the fraction. So that's going to be 2/3 over, so 3 minus 1, 2 minus a. So 2 minus a over 3, we can cancel them out. So the first approach, we came up with 2 over 2 minus a. So that's the first approach of, that's the slope of the Euler line using the first approach. So we also have a formula for the slope of the Euler line. So the formula of the slope of the Euler line, so for those of you who are interested in proving this formula, just let me know. I can create another video for this. But for today's video, let's just stick to this formula. So that's minus, so m sub 1, m sub 2 plus m sub 1, m sub 3 plus m sub 2, m sub 3 plus 3 over m sub 1 plus m sub 2 plus m sub 3 plus 3 times m sub 1, m sub 2, m sub 3. So what are these m's? So the m's, for example, m sub 1, they are the slopes of the sides of the triangle. So we can say, for example, PD or DP, that's the first side, PC, that's the second side of the triangle, and DC is the third side of the triangle. So according to this formula, the Euler line of this triangle, if you have the slope of this Euler line, we can, and if you have the slope of this sides of the triangle, we can calculate the slope of this Euler line. So let's just calculate, for example, m sub 1, for example, this part. So we have PD, that's the first side of the triangle. So using the 2 coordinates system, we can find the slope. So that's y sub 2 minus y sub 1, it is just 1, and x sub 2 minus x sub 1. So that's m sub 1, that's the slope of the first side of the triangle. Another one, let's go for PC, that's the second side of the triangle. So m sub 2 would be, so y sub 2, which is 0, minus y sub 1, which is 1, over x sub 2, which is 1, minus x sub 1, which is a. So in other words, minus 1 over 1 minus a. And m sub 3, it is 0 because this DC, the side of the triangle, it is parallel to the x-axis. In other words, the tangent of this angle is 0 because the tangent of 0 is 0. So tangent of 0 is sine of 0 over cosine of 0. So sine of 0 is 0. Then the slope is just 0. So this, luckily, this fraction, this nasty big fraction, this monstrous fraction will be way easier for us because a lot of terms, they just end up as 0. So now let's just substitute in this fraction because we have m sub 1 and m sub 2. So m sub e, which is the slope of the Euler line, equals negative this fraction. So m sub 1, m sub 2. So m sub 1 is 1 over a, and m sub 2 is minus 1 over 1 minus a. And then we have m sub 1, m sub 3. So that's 0 because m sub 3 is 0. M sub 2, m sub 3 is also 0. We just have plus 3 in the numerator. And then in the denominator here we have m sub 1, so 1 over a, plus m sub 2, which is minus 1 over 1 minus a, plus m sub 3, which is 0. And then this whole term is also 0 because there is an m sub 3. So let's just simplify that a little bit. So m sub e equals negative this fraction. So we can say that a times 1 minus a is the common denominator here. So that's minus 1 plus 3 times 3a times 1 minus a over, sorry, this was an addition. So 1, so a, let's find out the common denominator here. So that's 1 times 1 minus a. So then this thing becomes 1 minus a minus a. So we can cancel these two terms because they are in the denominator here, and then we can simplify that further. So 3a minus 3a squared minus 1, and this is also a negative here, negative sign, over 1 minus 2a. In other words, so now we found in another way this slope of the Euler line. So using the first approach, using the centroid, right? So we had the centroid at the first. Using the centroid and this corner, we found that the slope of this Euler line using these 2 points. And then using the formula of the Euler line, we found that the slope of the Euler line using all these slopes of the sides of the triangle. So these two things, they should be equal, right? They must be equal because they are the same thing. So now we just have one variable we can solve for a. So let me erase the whiteboard here. That's going to be really interesting at the end. And also this part. So let's start one more time using this part. So 2, let me change the color a little bit. So 2 over 2 minus a equals this fraction, right? The first slope and the second slope. So this fraction, let's just apply this negative. So that's minus 3a plus 3a squared plus 1 over 1 minus 2a. So let's just cross multiply that. So we can say that 2 minus 4a equals minus 6a minus 3a, minus 6a, right? That's right. Minus 6a plus 6a squared plus 2, and then this part as well, this minus a as well, we can apply that as well, so plus 3a squared minus 3a cubed, then minus a. Wow, that was long. So just pay attention to not make mistakes in this algebraic calculation. So let's just bring these two terms to the other side as well to make it more simple. So minus 2 plus 4a, and then we can set this part to 0. So we have minus 3a cubed, that's this term, so we have, that's a higher degree, that's the third degree. The second degree would be a squared, right? So 6a squared plus 3a squared, That's 9a squared. Yes, so plus 9a squared. Then the next term is just a, the first degree. So minus 6a, minus 8, minus 7a, and plus 4a, minus 3a. And then we have 2, minus 2, which is just 0. So we have now a third degree cubic equation, and luckily there is no constant term, then we can solve for a. So let's factor minus 3a. So minus 3a times a squared minus 3a plus 1 equals 0, right? So let's just make sure if it is correct. So minus 3a squared, 3a cubed, 9a squared, and minus 3. So that's right. So in this equation, so a could be 0 because minus 3a could be 0, then a could be 0. And it doesn't make sense because in geometry, a cannot be 0. A length has a positive value. It cannot be 0. So this is not our answer. This bracket is a quadratic equation. Then we can easily solve for that. In another way, another root would be, so minus b, which is just 3. So plus square root of delta, which is b squared minus 4ac. So that's 9 minus 4, that's 5 over 2. Another one would be 3 minus square root of 5 over 2. So square root of 5 is more than 2, right? This fraction is more than. This square root, this radical is more than 2. So 3 plus something more than 2 is 5 plus over 2, that's more than 2. And according to our initial setup, it doesn't make sense, right? Because we know that as we assume the side length of this square is just 1 unit long. So in this case, it cannot be possible. It is not correct. It doesn't make sense. So the whole thing is just 1. So a cannot be more than 2. So let's check this one. So 3 minus kind of 2, it's just 1 over 2, it's 1. So it makes sense. It is correct. It is positive, and it is less than 1. So I think that's it. Now our final approach, our final step is to calculate PB over PA, right? So according to the question, we need PB over PA, or this part, this segment, or this segment. So this segment, PB, is 1 minus A over A. So we have our A here. So let me erase the whiteboard one last time, hopefully. So let me write it down here. A equals 3 minus square root of 5 over 2. So now let's just substitute. So 1 minus A. So because the denominator here is 2, so let's just write it down as 2 over 2 minus 3 minus square root of 5 over 2 over A. So A is 3 minus square root of 5 over 2. So this whole fraction becomes, so 2 minus 3 plus square root of 5. Then we can cancel the 2's out, and then 3 minus square root of 5. So in other words, square root of 5 minus 1 over 3 minus square root of 5. So that's the answer, but we can simplify that further because there is a square root in the denominator here. So let's multiply that to its conjugate. So square root of 5 minus 1 over 3 minus square root of 5 times 3 plus square root of 5. 3 plus square root of, so 9 minus 5, it's 4. Then 3 square root of 5 plus 5 minus 3 minus square root of 5, which is, so 3 square root of 5 minus square root of 5, 2 square root of 5 plus 2 over 2 times 2. Then we can factor one of these 2's out, so it is 2 times square root of 5 plus 1 over 2 times 2. We can cancel one of the 2. So in other words, PB over PA equals square root of 5 plus 1 over 2. And wow, that's phi, or phi in Greek pronunciation. Beautiful, stunning, astonishing, super dazzling, I think, because so this thing is approximately 1.618, aka the golden ratio. And this is the twist I told you about right in the beginning. That's so beautiful. It stunned me right in the beginning. So according to this problem, whenever we have a square and there is a triangle inscribed inside this square, and if the Euler line of the triangle passes through this corner, so this ratio, PB over PA, it is the golden ratio, which is abundant in nature, probably in our body. Everywhere you can see the golden ratio. And that's so beautiful, so mesmerizing, so marvelous, so wondrous. And definitely there are many more approaches. And I would like to know your approach as well. That was something quite fascinating. So that's going to wrap it up for today, guys. I want to see your approach as well. So make sure to put your thoughts and answers in the comments below. And don't forget to subscribe and like and share if you haven't already. And as always, I love you guys. I appreciate you guys. And see you on our next video. Prime Logic signing out.